the first problem. First problem, a person is standing on the scale inside the elevator and elevator reads 30 Newton more. What does that mean? That means the elevator must accelerating up. So this is the typical case when normal force is bigger than the weight. Normal force is bigger than the weight is because the elevator is accelerating up, and the consequence is the person feels heavier. Now let's say the mass of the person is 100 kilogram. Just let's say mass of the person is 100 kilogram. All right, so the equation is Fn is equal to mg plus a. So Fn is equal to m, which is 100, g is 10, and a is, let's say, acceleration is 2. So Fn is 100 times 12. So Fn is 1200. So the mass is the scale will read 120 kilogram. That means the person will experience how much his weight, his mass initially was. His mass is 100 kilogram. Now the scale is reading 120 kilogram. The person feels heavier is because the elevator is accelerating up. Sir Isaac Newton. Okay, so elevator is accelerating up. So number one, a person is standing on a bathroom scale in an elevator car. If the scale reads a value greater than, again is the same problem. If the scale read, if someone is standing on a scale inside the elevator and scale read like, you know, the person, let's say the person is mass is again let's say mass is 80 kilogram. All right, 80 kilogram. The person mass is 80 kilogram. Then the scale would read more. That means elevator mass accelerating up. That means this scale would read more, and because elevator is accelerating up, because again the normal force is bigger than the weight. And what does that mean? How much the scale would read? We can even predict how much the scale. We can use the equation. Let's say the equation will tell us how much more the scale will read. We know that the person will feel heavier. So m again g plus a. So Fn is equal to m 80, g is 10, and a is 2. Let's say Fn is 80 12. So 960. All right. So the Newton. So the person will feel 96 kilogram, and 96 kilogram is more than the person is 16 kilogram more than the person true mass. So the person will feel heavier. Of course, then the answer would be the elevator must upward in so downward at constant speed. At constant speed, the person won't feel anything. It's normal. So this is wrong. Upward constant speed, the person will not feel heavier, will not feel lighter, feel normal. If the person is 10 kilogram, the scale will read 10 kilogram. It won't read greater value. There should be some acceleration. Now downward, so elevator car could be moving downward, increasing speed. Move downward downward means accelerating downward. Accelerating downward means the lighter. All right, lighter. So the person should feel heavier is because this is the greater. What does mean the greater? If person is 80 kilogram, then the scale would read 96 kilogram. If person is 80 kilogram, the scale will read 96 kilogram. Is because upward increasing speed. Upward increasing speed, it means the elevator is accelerating upward. Everything an elevator that is accelerating downward. Now in this problem is talk about acceleration directly, so it tells that the elevator is accelerating downward. That means the person should feel lighter, and that means if the person is 100 kilogram, if the person mass initially is 100 kilogram, then the scale would read less. How much less? Let's see. F n is equal to, remember the scale only read the normal force, so m g, this case is g minus a. Make sure you understand that. If you don't remember that, you always can write it down. So this is fn, this is fg. So f is equal to negative ma. So fn minus fg is equal to negative ma. So fn is equal to mg minus ma. So fn is equal to mg minus a. So fn is equal to m is 100 and g is 10 and a is 2. So fn is equal to 100 times 8. So Fn is equal to 800. So 800 Newton. That means the scale will read only 80 kilogram. 80 kilogram is less than 100 kilogram. So the person feels lighter. What does that mean? What is the weight here? Weight is 100 kilogram times 10. So 1000 Newton. The person weight is 100 Newton, the scale will read 800 Newton. That means, yeah, that means number 1. So number 1. 750 Newton person is standing in an elevator that is accelerating downward. Alright, so accelerating downward means the person would really feel lighter. So in this case, the person will feel lighter. The person. This is fg, this is fn. That means fg is greater than, fn is smaller than, fn is smaller than, fn is smaller than fg. What does that mean? Accelerating downward. What does that mean? Person will feel lighter. What does that mean? That means 750 Newton. So 750 Newton. So 750 Newton is 75. So this is 75 kilogram. So the person mass is 75 kilogram. So the scale will read less than 75 kilogram. You'll see that. So Fn is equal to mg minus a. So Fn is m. Let's say a is 2. We have been letting a is 2 from beginning. It's just, you can let a be 3 or 4 or 5 and it's still gonna give you the same answer. So mass is 75, g is 10 minus 2. So Fn is equal to 75 and this is 6. So Fn is 450 Newton. So that means mass, the scale will read 45 kilogram. 45 kilogram is much less than 75 kilogram. 30 kilogram less. So the person will feel lighter. So what is the answer? In fact, we know what is it. Is 450. If you let acceleration due to gravity is 10 meter per second square. All right. So the answer to the question is number 2.